So good day everyone. We are going to prove logical equivalences using biconditional statements. Now, we have already established that the P if and only if Q is logically equivalent to P implies Q and Q implies P. So then it follows that it is logically equivalent to not P or Q and not Q or P. Okay, so we will be using these two proofs as we go along. Now, our first task is to prove that the biconditional P and Q, so P if and only if Q, is logically equivalent to not P if and only if not Q. Okay, so we will work on the left statement. So we have P if and only if Q is logically equivalent to not P or Q as shown in the previous slide, this part. Okay, so let us remind you of what it actually evaluates to. So it is also equivalent to P implies Q and Q implies P. So we can evaluate it to not P or Q and not Q or P. Okay, now what we can do is to, what we want is a not P and a not Q. And our goal is that in order for us to have that, it should be equal to not P implies Q, okay? So we have the not P or the not of Q. And the not of Q using the double negation, and the not Q or the not of P. Okay, so now we can what we can do is use the commutative law by interchanging the not of not Q or not P, and we have the not of not P or not Q. Okay, this should be not. So our goal is that we want to have a not P implies not Q and not Q implies not P in order for it to evaluate to not P if and only if not Q. Okay, so now this may be written in as not of Q implies not P, which as I said, our goal, and not P or not Q. I'm sorry, implies to not Q. Okay. So now we can say that not Q is logically equivalent to not is a biconditional not P, and in which we can interchange it to not P biconditional not Q. Okay,